Hello, this is Shane Starrett, and today I'm going to be going over my final project for CSCI 349, Intro to Data Mining with Brian King. So the idea behind this final project was that we basically grab a data set, and this data set would either have a specific problem associated with it or would have a goal for the data to be evaluated to determine, something specific. So for the data set that I chose one that included 33 different attributes surrounding different students within a school or within multiple schools within Portugal. And the idea behind this data set is to evaluate these attributes to determine which ones are the most impactful towards student performance, and to see if we could create some machine learning model that can accurately predict student performance based on these 33 attributes. So this is where I actually retrieved the data set. It's from the University of California. That's where it was published anyway. It's actually originally from the University of Minho, which I'm assuming is in Portugal. And there's actually a paper that was done on this specific data set where they tried to do the same problem we were doing, where they were attempting to evaluate which attributes led to the best, which ones were the best predictors of student performance, and they attempted to make some models that could accurately predict student performance. So before I get into this research paper, let me go over what I have been able to accomplish. So as I stated before, there were 33 total data attributes. And most of these were either nominal or numeric, so cleaning the data wasn't that difficult. There was no missing data at all, and so there was actually two CSV files included in this data set. One for a math course that students had taken, and one for a Portuguese language course that students had taken. And so this is how I read them into the notebook. And these are the first three sort of records for each one. And obviously not all the attributes are shown here, but this gives a good idea of what the data might look like. And so what I ended up doing was I actually ended up combining these two data sets into one so that we could evaluate and predict student performance regardless of what course they were taking, as it appeared that grades within both courses were relatively similar. And I figured that being able to predict student performance across multiple different courses rather than just to a specific course is more valuable than just predicting for one course. So this is a description of what the variables mean. And I'm obviously not going to go through every single one of them. I'll go through some of the ones that had the most importance or are relevant to the data set. So this is the number of past class failures. They also include alcohol consumption throughout the week or throughout the weekend, the health of the student, the number of absences they've had. They included some demographic information like their family size, their age, their father's job, their mother's job, their parents' education, things like that. And there are three special attributes, I suppose, that are included. The final grade, or G3, is our target attribute. That's what we are attempting to predict from all the other 32 attributes. Now, G1 and G2 are possibly the most important input variables, and they're the first period grades and the second period grades. So think of it as like there's trimesters, and after the first trimester, you get your first period grade. After your second trimester, you get your second period grade. And so these two variables ended up being the most impactful for predicting the final grade. And so when I modeled the data and attempted to evaluate it, I evaluated the data including these two grades and not including those 2 grades, so that we could see the differences in how the models performed based on if it had the the first and second period grades to work with or not. And the research paper that was published about this data set also addresses this, and also evaluated the data set twice, including these grades and not including them, and they got varying results, just like I had. So as I mentioned before, the data preparation for this data set wasn't really all that bad. It was just converting a lot of object, how Python automatically ingested the data. They casted them as objects. So a lot of these just had to be casted to either numeric or categorical. That was relatively simple. And then, of course, I had to combine the 2 data sets, and then downcasted all of them as well. And importantly, too, I also converted every single variable to numeric eventually, and then standardized all of the data so that all of the variables were basically had the same, weight when being evaluated from the models, so that there was no bias there. And so that was sort of the purpose. This was the entirety of the data prep. Not too much going on. So there's a lot of different summary statistics that I was able to do within the data prep EDA file. This is the final report file, so I didn't include as many EDA examples because there's 33 attributes. You can imagine how many different graphs you can come up for those. So I included some of the important ones, or some of the ones that had a certain amount of relevance. So this is the count by course. You can see there's more Portuguese language students. The count by school, we can see that there's more students within the GP school in general, and that on top of that, in general, they have a higher proportion of the math students as well. By counting by the number of pass failures based on course, we can kind of see that proportionally speaking, the students in the math course seem to have just a little bit higher chance of having a higher number of pass failures than those in the Portuguese language courses. Interestingly as well, within the math courses, those on the higher end of absences tended to be in the math course, and the math course in general just had students that had a higher number of absences, which was pretty interesting to see. Similarly, the GP school, just in general had a higher number of absences. As I said before, the first, second, and final period grades for both courses were relatively similar. In general, the Portuguese language course typically had a tighter spread than the math course, though it would normally have more outliers as well, which I found to be interesting. You can see that in both the first and second period ones, as well as within the final grade box plot. And we can even do the final grade by school box plot, and then a hue by the course. And we can see that that's pretty similar, the tighter spread for the Portuguese language grades, but more outliers. It's relatively interesting. So for the models that I used, I made use of 2 models. I made use of a multiple linear regression model that would perform on the data set, including first and second period grades, and of course not including them. And then I also used a Keras neural network model that used k-fold validation as well, in an attempt to evaluate the data set. And the results that I retrieved were quite interesting. They were not what I was expecting. If you can see here from the performance results, obviously this is a regression problem because we're attempting to predict a numeric grade, and we converted all of our input variables into numeric variables and standardized them. And so what I found was that the multiple linear regression model, when including first and second period grades, was easily the best performer out of all the different variants of evaluating. And then the second best was the Keras neural network model, also including the first and second period grades. So I suppose that wasn't surprising that the models including the first and second period grades were the best, because the research paper that had performed evaluations of this data set also had the same findings. If we search by accuracy here, we can see that they actually state this in their conclusions. They say the obtained results reveal that it is possible to achieve a high predictive accuracy provided that the first and or second period grades are known. And so basically what they say throughout this paper, and what I was able to determine through evaluating this data set, is that the demographic results and really every single other attribute other than those two, the past performance grades, really don't do very well in predicting the final grade of a student, which is pretty interesting. There are some that are obviously more relevant than others, but there are a lot that are just irrelevant, seemingly, based on this data set. So then from there, interestingly, the multiple linear regression model performed better when the first and second period grades weren't included. And of course, the Keras neural network model, not including the first and second period grades, performed really poorly. You can tell through the R2 score here, it's actually negative. And so I found it interesting that it appears the multiple linear regression model is the way to go, and that the Keras neural network model, no matter the hyperparameters I chose, it just would never perform better than the multiple linear regression model. I talk about this somewhat in my in the discussion and the conclusions here about the possibilities of maybe the Keras neural network model not being set up correctly. Based on the labs we have done and the exhausting amount of tests I tried to do with the neural network model, I found that no matter what I had set the parameters to, and no matter how many hidden layers I had, for example, it would always just perform worse than the multiple linear regression model. And I talk about the different optimizers, the different activation functions I tried to use, the different numbers I used for epochs and for or epochs, however you want to call them, and batch size, and also the different number of nodes I had in the hidden layer. And honestly, I think this was one of the best, if not the best, result I ended up retrieving for the Keras neural network model when not including the first and second period grades. So I don't know. I like because just from my own intuition, from what I understand about data analysis and data mining, it's my understanding that the Keras neural network model should perform better than the multiple linear regression model as long as the correct hyperparameters are used, and of course as long as it's set up properly. So yeah, overall, basically what I ended up determining was that based on the multiple linear regression model, when first and second period grades are looked at, which is the one that performed the best, it had the R2 score of 0.836. What we found were that the variables that were most influential on the final grade were the number of past failures, weekday drinking, of course the first and second period grades, the number of absences, how good the student's family relationship was, and also the amount of travel time it takes them to get to school. So the number of past failures, obviously the higher that number was, the lower the predicted final score would likely be. That was similar with weekday drinking. That seems pretty common sense. Obviously, very interestingly, actually not obviously, the number of absences correlated very positively to a student's final grade, meaning that the higher number of absences that an individual had, the more likely they were to actually do better, and therefore the model would predict that they had a higher grade, which I found very interesting. That was true within the Keras neural network model and within the multiple linear regression model. Of course, a good family relationship also correlated with a higher prediction for a higher student performance, and also, oddly enough, travel time, the higher travel time you had, it seemed to contribute significantly to the prediction of a better final score, which, doesn't seem very intuitive, but that's the final results we ended up getting. And I found this interesting, and those were pretty much the most relevant variables within the data set. All the other ones pretty much were irrelevant. Had a you can see that within the modeling modeling pie file here, that when we look at the coefficients of not that one, but perhaps I think it's this one. Yeah, this is the one that performed the best. You can see like the school that they went to doesn't matter, their sex doesn't matter, their age correlates a little bit, meaning that the higher age they are, the lower they're likely to have a good score. Family size doesn't matter, mother's education barely matters, same with father's education. A lot of these just seem to be irrelevant or not have very high correlations. Whereas, of course, the at least not the first period, but maybe the second period grades did. And yeah, so in conclusion, really, I was happy to find that my conclusions were pretty similar to the research paper's conclusions. Again, they used many more different models. They not only used, they used decision trees, random forests, neural networks, and support vector machines. And they also turned this into not only a regression problem, but also just a classification problem, whereby they didn't just try to predict if the student what the student's grade was. They rather tried to predict if the student passed or failed. The grades were based on a score of 0 to 20, and so a student would pass if they got 11 to 20, and they'd fail if they got 0 to 10. And so they were able to use different classification models in order to work with different for evaluating the model in different ways. And so what they found was that failures and absences also were relevant on top of the grade 1 and grade 2 scores. Failures and absences were almost always relevant, whereas sometimes the travel time, sometimes the school they were going to, their mother's job, their mother's education, weekday alcohol consumption, they had relatively similar variables that they found to be relevant as the ones that I had, especially the most important ones like failure rate, absences, and the most relevant ones, sorry, not the most important ones, and number of failures. So, and of course, they had also stated that they found predicting student performance was a lot easier with the previous grades included. I found the exact same thing. Obviously, both models performed better when they were given the past student performance metrics and not the other 30 possible variables, or not just the other 30 possible variables that were included. So yeah, overall, I think what this sort of shows and what this can be used for really for future research, or just for those within the educational space looking to kind of interpret the results here. I think from the research paper that talked about this data set, as well as from my own conclusions, I think what can really be stated is that a lot of the variables included in here appear to be irrelevant, and that possibly a lot of focuses on what could possibly be impacting student performance might just be irrelevant, and that maybe it's best to focus on a small number of different variables within a student's life in order to, boost their performance or to help them within their academic, life. And, that perhaps, if past student performance is the go-to indicator of future student performance, then, maybe that, maybe there's just a lot of, still a lot of research to be done really in what the different variables are that lead to different student performances, because clearly a lot of the demographic information included in here, a lot of the social information, a lot of the family information that was, evaluated to help predict student performance just wasn't relevant. And maybe there's other variables that were not touched upon within this data set that possibly should be looked at, and they might be, impacting performance, but of course we can't evaluate that if we don't have the data. And so really the conclusion to take away, I think, is that there needs to be a better focus on finding other variables that possibly impact student performance, and also, of course, focusing on the ones that we know, to impact student performance, like alcohol drinking or the number of past failures, for example. Maybe, putting more focus onto those and figuring out ways to kind of make those, make students less likely to drink alcohol or less likely to fail a class. Kind of helping them through that might be the relevant focuses for someone who is attempting to, boost student performance within their specific school. So yeah, I think this data set is one that needs to be looked at a lot more. I think it could be possibly redone to maybe include more variables. I think that the ones that they did include were pretty, I don't want to say they were completely like robust and covered everything, but I myself had a difficult time coming up with other variables that could possibly be included in, the different questionnaires that they provided to these students to, help really find what are the variables that really truly contribute to, a student performing really poorly or really well. So I think this is an area that just needs more research done. And I'd be interested in seeing what future models, if there are any other researchers out there who actually attempt to evaluate this, what they'd have to find. Because based on my own findings and the one research paper that did look into this, it really seems that there's just some variables that are missing, that we don't know of, that are really contributing greatly to the to something with student performance, or maybe that there are just variables that contribute to student performance that just are very difficult to measure, or even that we can't necessarily capture with just numeric data or through just a questionnaire. Maybe it's something a lot more deeper than that. Maybe it's something that is a lot more difficult to acquire or to figure out than just having students fill out a questionnaire about multiple different aspects of their life and then evaluating that data to see which variables are supposedly the most important for predicting grade performance. I think there's a lot of different interpretations here, and so I don't want to make any swift conclusions saying that this data set is faulty and it doesn't really provide any relevance, since none of the variables really seem to show a super duper great impact on the predictions, except for the ones, of course, that kind of indicate past school performance, like number of failures and obviously the first and second period grades. So I think just more needs to be done with this data set, and possibly the data that this needs to almost be redone, like the entirety of this data set, the way the data is collected, the variables that are included, maybe need to be redone, because it seems like there's not very many conclusive results from this to be had from this data set, other than that past student performance seems to indicate future student performance, which, I mean, is pretty just common sense to me. So, I enjoyed working with this data set. I found it to be a lot less stressful than I was predicting, based on how many different variables there were. I was happy to be able to see that there was a previous research paper done on this, and the researchers within this paper helped me a lot when they were like with what models I should be using, and with the interpretation of my own conclusions. And again, I was happy to see that kind of what I was able to conclude was similar. Of course, not as robust or as in-depth as their conclusion, but it was very similar to what the researchers at the University of Minho were able to find. So I guess that's really all there is here. And yeah, I hope you enjoyed reading through my final report. I hope this video wasn't too long and convoluted. Have a great rest of your night, and thank you for listening to this shit show. I appreciate it.